So we're gonna do today is the lesson 8 of the unit 6. Okay, we have been learning how many methods to do the integrations. We learn use up, integration by part, partial fraction, trig integral, right? And then we also learn about trig sub. So today we going to decide. The goal for today is not to evaluate the integral, but the goal for today is to see which method is the most efficient for evaluate integration. Okay. I want you to going to be analyze the structure of the integral to justify the most efficient integration method. You will explain which method is the best and why it works for the certain integral. Okay? All right. So you will work individually first, and then I'm gonna give you time to discuss with your partner, and then we're gonna discuss at a whole class. So let's do it. All right. Let's do first number 1. Okay, I'm going to give you 1 minute on your mini whiteboard. Don't evaluate it. I just want you to write which method you think is the best to solve it, to evaluate this. Okay, and maybe you can write one sentence explaining it, because later you're gonna share with your partner. Okay, 1 minute. Let's go. So just give the name of the method you think is the most efficient to evaluate this. You don't need to compute this, okay? You don't need to evaluate this. Oh, good. So what integrand structure that stood out to you that you know this is going to be the one?
Because this one, we can fight, see if we can try and factor it.
Okay.
Because the power is great.
Okay. All right. Think about what is the sign? What is the sign of the numerator and denominator? That's like which method is you going to be rule out? That's they're not gonna work. That's your strategy. All right. Okay. Now I want you to share your answer with your partner. Okay. Maybe you're going to have a different method, but then you're going to decide. You're going to discuss which one you think is the most effective method. All right. Okay. 1 minute. Let's go. So turn and talk with your partner.
I kind of put partial fraction. I'm not sure. Yeah. I want to pay into like a plus b over something. Yeah. Usually, what do you think?
So I feel like it would be a more complicated method if you use integration by part. So partial fraction sounds more efficient.
Do you think this can be factorable? Do you think this is factorable? Yeah. Okay.
But I'm not sure. It may not be partial fraction because my assumption is not factorable. Yeah,
Okay.
not factorable.
What do you think? Why you chose this method? And same thing, Kareem, why you chose this method? So you all have the same method now, but why?
Partial fractions because the top, I mean, it looks like it could be split up into two.
Integration
And
by
the
parts.
bottom looks like it could be factored out, but since there's a 7, there's like a big chance that we'll probably have to do like complete the square
Mm.
to like break them up.
Very good, very good. So you can see that this is unfactorable, right? Because there's no number that's multiplied to 7 and that add to 3. That's what we learned on algebra 2, how to factor it, right? Okay, now I'm gonna count 1, 2, 3. Everybody, you're gonna raise the board, okay? Okay, 1, 2, 3, everybody. I see a lot of partial fraction. I will show partial fraction because we will able to bracket it. Very good. I see a lot of partial fraction. Oh, okay. Very interesting. Okay, keep it up. There's one answer. Actually, I see 2 different methods. I see partial fraction. I also saw use up. Oh, interesting. Okay. Now Irma, so can you explain to us why did you choose Yusuf?
Well, I chose
Very good answer. I mean, we have different two approaches we're gonna
Oh,
discuss.
let's describe it.
Yeah.
Oh. Well, I chose Yusuf mainly because you can factor the bottom part, which means we wouldn't be able to use partial fractions. And I
Uh-huh.
thought Yusuf would be like a method because I forgot, like in one of the lessons I remember that we learned something about being able to cancel it out, and then if we get, yeah, that's all I remember, but I know we can cancel it out at some point later on, and with Yusuf maybe.
Thinking about what Irma just said, right? She said, so I think a lot of you answered this is partial fraction. That also a very good thought. Now, Irma saw that, remember one of the lesson, what is the relationship between the numerator and denominator you see over here? Why Irma's talking, I saw a couple of you like, oh, like, I think you see something, right? So think about, is there any relationship between the numerator and denominator? That's maybe you have a different approach. Okay, Irma, can you want to elaborate more?
Numerator, I think, has a lower power than the bottom, than the denominator.
Okay,
Yeah?
before we settle on that, is anyone disagree or agree? Shirley, you have anything you want to add on?
I agree because at some point in the lesson you told us if we have to do long division. I think if we have if the lower denominator power is greater, I think if that's right.
Okay, who want to give a comment on that? When we will be using the long division? Okay, Kayla, right there.
I think I understand. I think I understand where you're coming from. I think though, however, it's when the numerator power is greater than the denominator power where you end up using long division as your method.
Right. So long division only doable when you have the power of the numerator larger than this. Do you remember when we do long division? We're gonna put something here, right? Like so, this power right here, the top one, the numerator, needs to be larger than the denominator. But that's a good thought. This remind you of long division. It remind you of the partial fraction. But I want to go back to Irma because the Yusuf, very interesting. Do you remember we learned what is the sign we're gonna use Yusuf? What is the sign when we're gonna use Yusuf? You want Valerie?
I think one of the signs was when it was in a square root
Square root?
or in a fraction.
Fraction, square root? Okay, how about this? How about this specific problem? There's no square root here. I don't see any square root here.
But you probably still could because it's a fraction.
Partial fraction? Partial fraction works, okay? But we want to find which one is the most effective method. And I see two different approaches. So that's why I want to pause and I want to discuss about that. Okay, anyone else? Okay, Brad, let's go.
When you use Yusuf, it's because if we take the derivative of the bottom, we'll get 2x plus 3, in which we could probably cancel out like an x. But I mean, I chose partial fractions mostly because even though the bottom you can't factor out perfectly, you could do like the complete the square, and then once you just do that, it's just simple to do the partial fractions. I chose that because I'm just more comfortable doing partial fractions, and that's like my preference. But I think Yusuf could definitely work here too.
Okay. So I think, let me rephrase what Brad just said. Maybe originally Brad thought this is going to be partial fraction because you see rational function, right? But then after Irma brought into the idea that this maybe we can use Yusuf because one of the lessons she recall is, and then Brad just say it is, when you see the derivative of one is the other one, right? Do you see anything here? The derivative of the bottom denominator, it actually give you the top. Well, it's not obvious yet. But what is the next thing we should do so that we can see it immediately? Irma, I think you have something in your mind.
Well, like I was just thinking that like once you find the u, which would probably be like the once you get the derivative of it, you can I guess it would be like the x squared plus 3x
Oh, okay,
would be
okay.
the
So
u.
your u is going to be
The x squared plus 3x.
okay. What is the du?
The du would be 2x
Plus
3.
okay.
And
Now, initially we thought, oh, this is look different, right?
then, yeah.
I think that's the reason why a lot of you chose partial fraction. But what can we do with this? Oopsies.
That's it both. Oh.
You're gonna factor it, right? What number you can factor? Right? Yeah? So now you can see that the derivative of the denominator is here. So that's the side you're gonna using the u sub. Right, question. So yeah, it's still the whole time. Okay. Yeah, so I think Irma is brought out the idea of using u sub, and actually I think we are u sub going to align best here. Do you agree? Because you don't need to do the partial fraction. It's going to be two things more complicated. U sub is faster because you cancel out this one. Okay? Now, any questions so far? All right, let's do number 2. Now, what if I just changing a little bit on the top? For example, I just have this. Okay? 1 minute, let's go. Again, just use the method and justify this. You don't need to compute it. You don't need to evaluate this. Okay. So what size stood out to you that you're gonna use in user? What do you think?
Because if you make the denominator
Uh-huh.
u, and you take the derivative of that,
Uh-huh.
and you would eventually divide both sides for the new
The new derivative.
yeah.
Uh-huh.
You would eventually isolate the dx by
Uh-huh.
itself, and then the
Right.
top you would know that du over 2x plus 4 equals to
Mhm.
dx.
Okay. So on the other one, we can do u sub because you see the derivative of the denominator. You will see that happen again in the numerator. So that's why they can cancel out. So think about here. What's the difference? What if you take the derivative of the bottom? What you're gonna have? Think about that. Okay. Think about that. All right. Now I'm gonna give you 1 minute. You're gonna share with your partner your answer, and then decide which method is the most effective method. Okay. Let's go. 1 minute. Oh, okay. So I see two different approaches here. So what do you think?
I put u sub because if we just take like the derivative down here, we'll get 2x plus 4. And like integral of dx would just been x. So I thought if we just like take out a 2, we could have just had x over x plus 2, and then with like a du, this would have canceled out to like du times 2. But that doesn't seem right anymore.
So what is the sign that we can use the user phone on the first example?
That
Because
the derivative at the bottom must
Very
be the
low.
derivative at the top.
okay. Now you think about on number 2. If you take the derivative of the bottom, what do you see?
I'll get 2x plus 4.
Right. Does it happen anywhere on the top?
No.
So think about this. Think about the difference between problem 1, problem 2. Now, Granny, what is the feature of the integrand here that you chose partial fraction?
I chose it because I thought that like if you factor out x from the denominator, then you can split it up into the a over
Okay.
x plus b over x plus 4, and then
Okay.
you'd find like a and b.
Then that's the sign you're gonna use partial fraction.
Yeah.
Okay, very good. All right, I'm gonna count 1, 2, 3. I saw 2 different methods. I'm gonna count 1, 2, 3, and everybody gonna raise your ball. Okay. Okay. 1, 2, 3. Everybody. Good. I actually see two different approaches. Let's talk about it. Okay.